Okay, good morning. So let us continue our discussion about vectors. So far we introduced the notion of vectors, we learned how to add them, subtract them, and we also learned how to multiply just a number into a vector, yes? Now we want to define another operation between two vectors, and that's called the dot product of vectors. The reason that I have given you an adjective of dot product, or sometimes people call it an inner product, is that because we have also another type of product, yes? So this is the first one that we want to study today, and that's also very important. So if I want to give you some kind of motivation, I don't know how much you have studied physics, but if you want to find the work done by a force, you know what the formula is? So assume that you have this horizontal surface, and then you have a block with mass, I don't know, m or something. You can assume that this is frictionless or whatever. And then you actually, I don't know, you can just pull this, let me just call this a point. So you can pull this with a force. Of course, if this force is not that strong, this block, if this block is heavy, you can imagine it that way, this will not, of course, follow you. This will follow this path, yes? And then it will move, for example, from here to here. Let us say that this displacement is d. So, yes? So, of course, in physics, you know that the force is a vector quantity, and the displacement is also a vector quantity because not only it contains a magnitude, it also has a direction. Now assume that this is your setup. You have a heavy block, and then you can pull it gently because there is no friction. It doesn't matter if this force is so strong or not. You'd be able to pull it towards you. But if this is so heavy, it will remain on the surface. So that would be a little bit artificial, but you can imagine something like this can happen. Do you know how much work will be done by this force if I take this from here to here? Yes?
The formula for work is
Yes.
Force multiplied by distance, right?
Not exactly. That's what I'm just saying. Distance should be defined. In which direction? In the direction of the force applied. Yes, if the force and the displacements are actually collinear, then the formula that you mentioned is correct. So if I want to pull this block horizontally with a horizontal force, then the magnitude of the force multiplied by the displacement would be the work done by that force during this displacement. But now if I have something making an angle, I don't know, have you studied this one as well? So what is the formula? Have you heard about that?
Force cosine.
Yeah, so it would be, so the work that you are doing here is the magnitude of the force. So this is why in physics do not see this vector dot there, because this f, this is the vector f, but what you write here is the magnitude of f. If I want to write it in the mathematical, so this is the formula that you have in physics. Yes, this angle is theta. I don't know, have you seen this formula before? Yes. But now, if I want to write it in mathematical language, instead of f, what I mean is the magnitude of the vector f. And this is the magnitude or the norm of vector d, and then of course you have cosine theta. Yes, so these kinds of products are ubiquitous in physics and different parts of mathematics. So people have given it a name. This is called the dot product between the force F, and you have to write this dot. Okay, this is called the dot product between the vector F and the displacement vector D. Okay, so that is the definition. So it is a little bit motivated from physics, but we can do it formally mathematically. So I would say definition. Let U and V be vectors. the dot product, the dot, or sometimes people call it inner product, you have to write this dot. It's not like algebra that it's optional. Because we have two products, we have to mention which we mean. So you have to write this dot product. So the dot product u dot v is defined as follows. One, if is defined as follows. It is 0, not vector 0, it is number 0. It is 0 if u is equal to the 0 vector or v is equal to the 0 vector. Of course, or in mathematics is not exclusive, it means or both. Number 2, u dot v is equal to the norm of u multiplied by norm of v multiplied by cosine theta, where if u is not the 0 vector and v is not the 0 vector, here theta is the angle between two vectors, between u and v. So you see this combination is very, very similar to that combination. It's actually the same combination. So in physics, in the high school level, probably you don't write it in this form, you write it in this form. That is exactly the same thing. Yes? So what I'm saying to you is that I want to define a new operation between two vectors. That is called the dot product between two vectors. If at least one of these vectors is the 0 vector, you don't need to do anything. The answer is 0. But if none of them is equal to 0, how should I calculate it? I measure the length of the first one, I measure the length of the second one, I also measure the angle between them, and then I multiply these three numbers. Then I get the number which is represented. So there is a very big difference between this new operation and the operations that we had so far. Addition, subtraction, multiplying a vector by a number. What is the main difference between this new operation and those operations? Of course, they are very, very different, but I just want you to see if you see the point. Yes?
Is the answer for this a number?
Exactly. And this is why people sometimes even call it a scalar product, because the answer is a scalar. So that's the main difference between this new operation with the previous operation. So this is the first time I give you two vectors, you do something on those vectors, but the answer is no longer a vector, it's just a pure number. Yes? So that's the main difference. And of course this makes sense here. The force has a direction and magnitude. Displacement has a magnitude and direction, but if I ask you what is the direction of work, it's meaningless. So this means that what you get is a just number, is a scalar. You cannot say that what is the direction of energy or what's the direction of work. Yes? So we were able, so sometimes you see that this is forced upon mathematicians by probably physical concepts. Sometimes you are dealing with vector quantities, but the quantity that you are interested in is not a vector quantity, is somehow related to vector quantities, but that's just a pure number. Yes, is that understandable? Okay, so let me just start trying to make some examples. So, very simple example, yeah. let U and B be vectors such that the norm of U is, say, 2 length unit, whatever it is. The norm of V is, say, 3, and the angle between them is 30 degrees. Calculate, I don't know, for example, we can say 3a dot b, I can write a square, and then I can write, I don't know, for example, absolute value of a dot b plus 5. For example, I don't know, whatever you can make up. But what I want you to understand before doing any calculations here, I want you to understand and feel that what I have written here is actually meaningful. Yes? Is that understandable? Because, oh, yeah, that should be U and V. Sorry. So, this is completely meaningless, yes? Yeah, but this is meaningful, hopefully, now. Yes? So here, U dot V is definitely a number, and it makes sense if I raise that number to power 2. Yes? For example, if you see this notation somewhere, this is meaningless. Yes? If I write the vector A and put the power on top of that, this is meaningless unless I have to define it first. Because this operation makes sense when I have a number and then I multiply that number by itself and I denote it by this. So this notation doesn't make sense here. But this notation makes sense. Why? Because U dot V is a number, and of course I can raise that number to power 2 and I can multiply this by 3, and then this means absolute value of that number. So that's a number, I can add it to 5, it becomes a number, so the whole expression is definitely a number at the end. Yes? Okay, so if I want to calculate this, let me change my color. So it's very simple. First of all, what I have to do, I would calculate U dot V. So let us repeat the formula. So the formula tells me that this becomes the norm of the first one, multiplied by the norm of the second one, multiplied by the cosine of the angle between them. So the norm of U is 2, multiplied by norm of V is 3, multiplied by cosine of 30 degrees, yes? So what would be the answer? This would be 6, and cosine of this one is the square root of 3 over 2. If you multiply them, the answer would be 3 square root of 3. And then the question mark becomes equal to 3 times 3 square root of 3 to the power of 2, and then absolute value of 3 square root of 3 plus 5, yes? So in the numerator, if I multiply them, it becomes 81, and this just simply 3 square root of 3 plus 5. That's it. That's my number. It's not a big deal actually, so that is the number. Is there any questions? Okay, so do you think that this dot product can be negative, or is it always positive? Can the dot product be 0? Of course the answer is yes. At least if one of the vectors is equal to 0, I definitely can have the dot product equal to 0. So there are some questions I want to ask you because I want you to understand this deeper. Do you think, is it possible for having the u dot v for some vectors to be a negative number? Yes?
Distance can't be negative.
No.
And cosine can't be negative. And I don't think you can have negative
No,
force.
but your understanding is correct, but your conclusion is wrong. The distance cannot be negative, but that is not a distance anymore. I'm not talking in physics now, I'm talking in mathematics. So what you want to say, you say that this cannot be negative, you are right, because that's a norm of a vector. This cannot be negative, and you also told me that cosine cannot be negative, but why? We have studied that cosine can be negative in principle, yes? Because if you are, by the way, do you remember I told you a crucial point? What is the limit of the angle between two vectors? Can the angle between two vectors be 270 degrees by convention? No, the definition was somewhere between 0 and 180. And if it is bigger than 180, you will not count this one as the angle, you will count the smaller one. So be careful. When we talk about the angle between two vectors, it starts from 0 or up to at most 180. And of course, if you are from 90 to 180, you are in the second quadrant. And in the second quadrant, cosine can be negative, and the whole product becomes negative. Because you are multiplying three numbers, there is no hope for making something negative from these two. They are always non-negative. So this becomes, if this is positive, the product is positive. If this is negative, the product is negative. So I can say that u dot v is positive if and only if theta is an acute angle. Yes? And I can say that u dot v is negative if and only if theta is an obtuse angle. Yes? So acute means between 0 and 90. Obtuse means after 90 but before 180. Yes, these are the words that we use. So first of all, that's completely clear that it could be negative. So for example, let us go back to this setup. If I want to see it, of course, if I increase the angle, this will not move in that direction. It will move in the opposite direction, yes? But I can have a friction force here acting. Assume that I am pulling this, let me write force of friction. It acts in this direction, yes? Probably you have heard about that in physics, that you need to consider the work of the friction force as a negative value. Or I don't know, have you heard about that? But you really don't need to memorize that. If I ask you what is the work done by the friction force, if I ask you what is the work done by this force, this is the formula. But now assume that I move this object from this point up to that point, and I ask you what is the work done by the friction force. So what is that? So the work done by the friction force, let me write WF for friction, is equal to the norm of the friction force, yes, multiplied by the distance, the norm of the distance, multiplied by the cosine of the angle between the friction force and the displacement So what is that angle? Yes, it's 180. Yes, and then it becomes cosine of 180. What is the cosine of 180? It's -1. And then in physics you say write minus FFD. But that minus is actually coming from that because there is one definition for the work, and that is this formula. And then if you calculate that formula for this setup, because theta is an acute angle, you get a positive value at the end. But because if I want to do the same definition for the friction force, because the friction force and the displacement are making a 180 degrees angle, and cosine of 180 is -1, you always have this negative sign here. So might be in physics courses you learn in this way. If you are calculating the friction force, put a negative sign there. But the negative sign is actually coming from here.
So
Okay. So, but let me ask you one more thing. We know that at some particular values, in some cases, the dot product is defined to be 0. But do you think I can have non-zero vectors, but still the dot product becomes 0?
Yes.
When?
None.
Yes, when they are perpendicular. Yes, because even if u and v are not zero vectors, but the angle between them is 90 degrees and cosine of 90 is 0, so the dot product becomes 0. Okay, so that's also very, very important to write. So I would say that let me write this as a remark because that I will use a lot. So if someone tells you that u and v are non-zero vectors, if someone guarantees that, but tells you that u dot v is equal to 0, not as a vector, as a number, then definitely you can conclude that u is perpendicular to v. And the other way around, of course. If they are perpendicular, you can conclude that u dot v is equal to 0. So that's an extremely important thing. Whenever you want to show that two vectors are perpendicular, one way to do that is to multiply them using this dot operation and show that the answer is 0. If you succeed to do that, then it means that they are perpendicular. Okay. Something that would also be useful in the future, I will write it here for you, but then we will use it when we reach to that point. So some people want to calculate the angle between two vectors. So what we can do, let me also write this under the remark here. Okay, in that setup, you can write cosine of this angle is cosine of the theta is actually u dot v divided by norm of u multiplied by norm of v. That's the same formula. I have rewritten it in a way that you can see cosine theta on the left hand side. So hopefully you agree with me, that's the same definition, yes? If you multiply both sides by this, you get the definition of this. I will come back to that later. Okay, so let me just now write you a theorem, which is very important. I want to understand most parts of the theorem, except one of them. I will come back to that point later a little bit. So I would say that let u, v, and w be vectors. Okay? Okay, now let us understand this together. If I take a vector u and dot product it with itself, what would be the result? You take a vector and dot product it by itself. What would be the answer? Yes?
The angle between them is 0.
Yes.
So 0.
No, the angle between them is 0, so cosine of 0 will be involved.
Oh, so it's 1, so it's itself.
It's not itself.
No, it's...
So it is. So let us write it down. So if I ask you what is u dot u, what you do, you can say it is the norm of the first one multiplied by the norm of the second one, which accidentally here is again the same, multiplied by the cosine of the angle between these two vectors, but this vector itself make angle 0, and the cosine of 0 degrees is 1. So what happens? A number multiplied by itself is its norm squared. Yes? So this becomes norm of u squared. Be careful. And sometimes I can write it in this way. If you are interested in the norm of a vector, you can write it as a square root of u dot u. Be careful, u dot u is not u squared. U dot U is just U dot U. You have to write it U dot U. So this is the very important fact. We want to use it over and over again, and this is the reason, which was very simple, of course. Now let me ask you one more question. Do you think I have commutativity for this operation or not? Do you think this operation is commutative? Let us think about what does it mean. It means that if I multiply U from the left, would it be the same if I multiply it from the right? Is it commutative, do you think? The answer is yes, because this means the norm of the first one, the norm of the second one, and the cosine of the angle between them. This one is the norm of the second one, the norm of the first one, the angle between them, but because that one becomes again theta, yes? Because these are the same two vectors, yes? Okay, then what happens? This number definitely is equal to that number because cosine theta is cosine theta, and these are just numbers, so it doesn't matter in which order I am multiplying them. So this is commutative. What do you think? Do you think it is also associative? Yes or no? So you see, those things we took for granted for numbers, there's no guarantee they will actually pass through other subjects. We have to check them every time we define a new operation. But is it associative? Yes or no? What does it mean, associative? It means that, do you think this is equal to this? The meaning of being associative is this. Is it associative? Yes?
I don't think so because the angles are different between something with angles.
The first part I buy it. No, it's not associative, not because of that reason. Because this is not defined in the first place. It doesn't make sense at all. Why? Because if I ask you, this operation dot makes sense only on the left-hand side and the right-hand side of that dot you have vectors. Is that understandable? Yes? So this combination doesn't make sense at all. Because if you do this, what happens? The output is a number. And then I don't know, you have U dot 5. This dot is not defined for this combination. It is defined for two vectors. So this is just completely nonsense. So this is not associative because it is not meaningful. Yes? It's not associative. So just write it somewhere if you want to. But do you think this operation makes sense or not? Do you think this expression you see on the board is meaningful or still meaningless? Yes?
It's meaningful because U and W becomes a number, and then that number multiplied
by a vector makes sense. So what would be the result at the end? Would it be a number or would it be a vector?
It would be a vector.
It would be a vector. So you see, be careful. This is why I'm emphasizing when you mean dot, you have to write dot. Yes, you cannot be lazy. Because this is meaningful, this is meaningless. Be careful about that. Okay. So the next one that I want to talk about, so commutativity, we still have it. Associativity doesn't make sense. Distributivity, we also have it, but the proof is harder. Okay, we will come back to the proof a little bit later. So what I would write for you here is that U dot, if I have V plus W, I can distribute the dot product over addition. Yes, so I can write U dot V plus U dot W. Distributive, yes. That is correct. Okay, but the proof is harder than the previous one. But let me ask you something. Is this addition a normal addition, a primary school addition, or this addition is a primary school addition, or none of them? Yes?
The first one is not.
Is not, but the second one is. Because this second one is between two numbers, this first one is between two vectors. And of course, if you want to, you can also have this one. It doesn't matter, you can also distribute it over subtraction. Okay, another thing that I want to mention is, if you have a number, so let me write 4, let U, V, and W be vectors, and let alpha be a number. Let me add this one as well. Okay, now this, okay, let me ask you something. If I write this U dot V, and I put alpha here, how do you interpret when you see this combination? Alpha is a number, U and V are vectors. So this is what? This is of course a product, but a product between two numbers. So that is just a normal multiplication, a number and a number. Okay? But the theorem wants to tell you that it doesn't matter if you multiply alpha by the first vector and get a new vector and dot product that vector with the vector v. That would be the same number. Okay? And then of course it doesn't matter if you do it with v, writing u and multiply it by alpha v. So if you multiply the vectors using the dot product, get a number and then multiply numbers, you get the same number if you first multiply alpha into your vector, get a new vector and multiply this new vector by dot product into that vector. You get the same number. And the same thing happens if you do. What I want to say, I want you to remember it in this way. If you have a scalar, it's actually floating around. You can move it from here to here, or if you want to move it from here to there. Yes? So this is something that I want you to know. But let us understand it why. Yes?
So if you have a number inside a product,
yes,
you can factor that out.
It's not called factoring, you can pull it out.
Yeah.
Because, yeah. So for example, if I have u dot square root of 3v, I can write it as square root of 3 times u dot v. And by the way, because of this property, I really don't need to put pair of brackets around that. So if you see something like this, that is also meaningful. Because it doesn't matter if you multiply 2 by u first and then multiply it by v, or you multiply these vectors first and then multiply it by 2, so the answer is the same. So we don't have to use pair of brackets to prioritize which one we have to do first. Yes? Okay, so, but why this is true? Let us try to understand it a little bit. So the only one that I haven't talked about the proof is the number 3. We'll come back to this later, but we can prove this one. We can consider some cases. If alpha is 0, everything is trivial, agree? If alpha is 0, 0 multiplied by any number is 0. If alpha is 0, this becomes the 0 vector. The 0 vector multiplied by dot product to any vector by definition is 0. So for alpha equals to 0, this makes sense. I need to consider two other cases. One alpha positive, one alpha negative. Alpha positive is simple, so let me just do alpha negative, yes? And try to understand it together. So let me see which one we can. Of course, let us only prove this one. What I do for this one, you can do similarly for this one. I consider only the case alpha is negative. Of course, you have to do it for alpha positive as well. So if I ask you what is this one, alpha u dot v is equal to, instead of alpha I write alpha, instead of this one I use the definition. Cosine theta. If you don't mind, let me write, don't use theta here. I would write alpha. Instead of this one, I put norm of u, norm of v, cosine of the angle. Do you remember I use this symbol sometimes? The angle between u and v. Yes, is that understandable? So that is the meaning of that one. But of course, because these are numbers, do I really need this pair of brackets? No, that's a product between numbers. So I really don't need to write. I can write alpha, norm of u, norm of v, and then I can write cosine of the angle u and v, and this one. So this is the left-hand side. I expanded it, I got that expression. Now let us do the same thing here. Can you help me to do that one? So I want to write something for this. So what can I write? It's a dot product. We learned today what to write. So what should I write in front? Yes? What should I write? The norm of the first one, but the first one is this. So it becomes the norm of the first one multiplied by the norm of the second one, but multiplied by the cosine of what? The angle between two vectors. Which vectors? Alpha u on the one hand and v on the other hand. Yes? But do you remember, how can I pull this alpha out? We had it before. This becomes absolute value of alpha, and then we have norm of u, norm of v, yes, and then I have cosine of the angle alpha u v. But now I'm assuming that alpha is negative, so can I remove this absolute value sign? Yes, but the price that I have to pay is to put a minus sign there. So this becomes negative alpha, norm of u, norm of v, and the cosine, I shouldn't write this dot here, cosine alpha u v. Okay? So I was able to show that the left-hand side is equal to this expression, the right-hand side is equal to this expression. I have to convince myself that these are exactly equal. But are they? Yes?
In magnitude, they're completely equal, but not in direction.
No, but if that is the case, I cannot write equal.
Yeah.
Because for them being equal, they are numbers, they have to be equal both in magnitude and direction. But no, they are both equal in equal completely. Why is that? Because of course you have a negative sign here, but what you see here is not exactly that. It's alpha times u and v. Yes? And alpha here is negative. So, if I ask you, if alpha is negative, what is the connection between this angle and this angle? Are they the same? If they are the same, then we are in trouble. You are right. Because if they are exactly equal, then I don't know what to do with this negative sign. But are they exactly equal?
No.
No. What is the relation?
Well, u would become minus on the left one, where it's alpha.
No. Be careful. We don't have negative values for the angle between vectors. I just told you.
The u on the right, with the right angle, has a complete opposite direction of the with alpha one.
I understand what you say, but I want you to tell me the exact thing. Because you know, can I say that the angle between two vectors is 30, the angle between another pair is minus 30? No, it's not acceptable by definition. But you are on the right track, but I cannot say minus 30 is the angle between two vectors. This is a vector, whatever it is, even if this is negative, at the end this is a vector. That's also a vector. An angle between two vectors cannot be negative of the angle of another pair, because this means that this one of them should be negative. but the angle between two vectors by definition should be somewhere between 0 and 180. So how can you do that? So you were on the complete right track, but the answer is not negative. Yes?
Cosine of...
Forget about cosine. What is the relation between these two angles?
They are mirrored.
Okay, but how should I write? I cannot write they are mirrored. Yes, I need to find the relation between them. So what is the meaning of mirror? Yes. If two angles are somehow mirrored of each other, so how can I write them? One of them is 180 minus the other one. As simple as that, isn't it? So for example, if you have two vectors, u and v, for example, if this angle is theta, all of you were correct actually, but you need to find the correct word. If I multiply alpha by this vector, I don't know the value for alpha. It might be longer than this one or shorter, but one thing is sure, we are sure about it. The direction would be the opposite side. So I don't know the length, but the direction of alpha u, regardless of this length, shorter or longer, it would be that direction. Now if I ask you what is the angle between alpha u and v, you shouldn't point to this angle, you should point to this angle. Yes? And then you can see that this angle is 180 minus the other angle. Yes? So I hope that you could understand what I said. So are you happy with what I am writing right now or no? Yes? So this one is not exactly equal to this one, it's equal to 180 minus this one. Yes? So you might say that what happens, yeah, that's correct. No, that will be, even if this angle is big, yes, that's correct. Okay, and then if I have two angles, they are supplementary angles. And then cosine of one of them is negative of cosine of the other one. And that will bring me an extra minus sign that I can get rid of this minus sign. Yes? So this means that if I ask you what is cosine of alpha u and v, you would say cosine of this angle is negative of cosine of this angle. Agree? So now instead of this expression, I put negative cosine of u and v. That negative sign coming from here and that negative sign coming from absolute value cancel each other, and then I will get exactly the same expression. So that is one, that's exactly the proof of this one. So now, after understanding them, I want to memorize them and use them freely, okay? So we can say that if I have a scalar and I have a dot product, this scalar is floating around. You can just move it around wherever you want to, yes? Is that clear? Okay. Now, so for example, let me write some of these things here. I want to make sure that you understand these operations that I do freely and quickly are valid. And of course, I want you to be able to do the same thing. You don't need to always refer to the fundamental parts here, but you can imagine that. For example, if I tell you A dot 3B, can I simply write 3A dot B? Yes? Yes, that's correct. If I tell you 2A dot 1/3 of B, are you happy if I write 2/3 of A dot B? Yes?
Yes.
Yes, that's correct. Because what can I do? I can move these two inside the other one. And when I move it 2 times this vector, it becomes 2 times 1/3. So it becomes 2/3, then I can pull it out. But you need to understand all these properties behind them. So let me write some for you here. So for example, what do you think about this? Do you think this is a correct argument or not? Is it true or false? So if I want to write it, true or false?
True.
It's true, yes, because 4, I can write it as, I can pull this minus 5 out, it becomes minus 20, A dot A. But another way of writing A dot A is to write the norm of A squared, so that's also correct. So, might be some more interesting one is, what do you think about this one? Can I write A dot 2A minus 3B? Can I distribute it inside? Like algebra. Can I or not? Yes, we can, yes. If I want you to quickly write it like this. Okay, I want you to be able to do quickly this, but if I want to do it in piece, so what should I do? I would write A dot 2A minus A dot 3B. Yes? And then this is floating around, so I can pull it out, then it becomes A dot A. Then this 3 I can pull it out, it becomes minus 3A dot B. But instead of A dot A, it is better to write the norm of A squared, and then minus 3A dot B. Yes? I don't want you to go through these steps. I want you to be able to immediately write that, but I want you to understand and write that. Yes? Is that clear? Okay, another question. Do you think I can write something like this? A dot B, and then I would write A, and then I would write dot C. Do you think that I can write it as A dot B, A dot C? And what is your interpretation? Do you think that this is a true statement? I have to be careful about writing these dots. I am putting a dot here, I am putting a dot here. Is it true or false?
True.
Yes, why?
Because A and B becomes a number.
Yes.
Then you can float out and put.
Then this will be multiplied by that. Yes? Am I allowed to put, if I put here, something here, it becomes completely meaningless. Yes? Because this becomes a number, I cannot, when I have this symbol, the left hand side and the right hand side have to be vectors. So I am not allowed to put dot. So if I don't put dot, this is meaningful and this equality is valid. Yes, is that understandable? So this is a product. This you see, if I ask you what type of product you see between these two, what type of product you see here, it's called dot product. What kind of product you see between here, it's called scalar product, multiplying a number by a vector. And again, what type of product it is of a vector, and a vector is a dot product. So that's a dot product, that's a dot product. What product is here? What?
Scalar.
What do you mean by
Between two numbers.
between two numbers? Yes. Yeah, exactly, just normal product between two numbers. So you need to have a good understanding about these things. So what do you think? Do you think this is right or not? Let me write something here. A dot B, A. Dot A dot B, B is equal to A dot B to power 3. You can think about it. First of all, it makes sense. Do you agree? What I have written makes sense, either true or false. Yes? But is it true or false? It is. It is. Yes?
Okay, so it feels like it should be true.
Yes, it is true. But why is that true? No, it's not. It shouldn't be hard. It's a number. It's also a number, and I have a dot product. I can float them around. Yes. So I can pull both of them out. So what happens? It becomes A dot B coming from the first one, A dot B coming from the second one. But what would be left for me? A dot B. Okay, and how many A dot B's you see? 3 of them being multiplied, so it becomes A dot B to power 3. Yes? So these things I want you to be quick when I ask you to do calculations, yes? Okay, now let us go to more interesting examples. Okay, so let us start with formal examples now. So remember, the only thing that I haven't proven rigorously for you is distributivity, yes? But you need to, for the time being, trust me on that. Okay, so let U and V be vectors such that norm of U is 2 and norm of V is 3. If the angle between these two vectors, between U and V, is 120 degrees, determine the exact value of 2U minus 3V dot product with 4U minus V. Now let me make this one positive. It doesn't matter, of course. Okay. So I want to see how do you think about this problem. I have two vectors U and V. I have given you the norm of each vector, and I have given you the angle between U and V. But now I am asking you calculate the exact value of this dot product. First of all, I hope that you don't have any problems with the exact value, because you know that what would be the result at the end would be a number. This is definitely a vector. But because of this dot product, the final answer would be a number. I'm asking you about the exact value of that number. So everything makes sense. The only thing is that how we should solve it. The reason that I brought this example right here, because I want to change your way of thinking. I don't know, might be because of my experience, people start thinking about finding the norm of this, finding the norm of that, and finding the angle between these two, so that they can plug this into the main formula and get the answer. Of course, this is 100% correct, but there is a big if. How can I find those values? Yes? So there is no general way right now. Of course, we will study that, by the way. Yes? But there is a simpler way to do this. I can find the norm of this vector if I want to. I can find the norm of this vector if I want to. I'm not that optimistic if I can find the angle between them exactly, based on the angle between U and V. Yes? Yes, do you feel that finding the angle between them is not that probably simple? I know the angle between U and V. Then from those I make this combination, and I make another combination, so I will have two new vectors, and then I want to find the angle between them. Is that understandable? So it is not that trivial that what is the angle? By the way, we can find this angle with a different method, not right now. Do you have any alternative to solve this problem? I can give you a little bit of time, but my guide for you is to use the theorem. parts of that theorem. Okay, so I will pause the video. Okay, so let us now continue. So could you find something for me? Or at least do you have any suggestions? How should I start? Yes, distribute them. But should I be really careful? No. The properties that I need is exactly as before. So if I multiply this by that, one thing that you need to remember, you're not allowed to suppress this sign. You have to put it when it is necessary. So if I want to, so let me write the exact value. So the question mark is equal to. I multiply this by that, so it becomes what? It becomes 8. Let me write everything once. U dot U. Yes? And then I multiply this by that, it becomes negative 2u dot v. I hope that you understand that this is doable. Okay? And then this multiplied by that is how much is 12 v dot u. And the next thing would be negative 3v dot v. Yes? Is that understandable? So that's distribution. But instead of this, what can I write? I can write norm of u squared. Can I combine these two together? Can I say they are similar? Yes, because of commutativity, yes? So I can write plus 10 u dot v or v dot u, it doesn't matter. And the last one is minus 3 norm of v squared. Yes? What information is provided for me? I don't have any problems here, I have it. I don't have any problems here, I have it. But this one also, I have the formula for it, yes? So what happens, so it becomes, let me just write it again. This becomes this, plus 10. This becomes norm of the first one, norm of the second one. But the angle between which vectors? Exactly those vectors that I need. Yes? Minus 3 norm of v squared. So you see that this question mark is written in this form, but in this expression, everything I need, I have it. Yes? So, but just I need to calculate what is cosine of 120. So 120 is a supplement to, is the supplement of 60, yes? So it becomes cosine of 180 minus 60. And I think if you imagine it in your head, it becomes negative cosine of 60. And cosine of 60 is 1/2, so it becomes minus 1/2. Yes? And then the rest of it is just plugging in the numbers. So it becomes 8. Let me just use this symbol for, but that will also be problematic later. But for the time being, we can use this. So then it becomes to the power of 2 plus 10 times, instead of u I put 2, instead of v I put 3. And instead of that, I put minus 1/2. And then I have minus 3 times 3 to the power of 2. So if I calculate this, it becomes 32. This one becomes minus 30. Am I right?
Minus 60. Oh wait, yeah, for the whole.
Yes, for the whole. And then this becomes minus 27. So what happens? It becomes 5 minus 25. Am I right? So the answer to the question mark is minus 25. But my question for you is that, do I know after this calculation is done, do I know something about the angle between this and that? Some information. I'm not asking you the exact value, of course. But I'm asking you, by calculating this and seeing that this number turns out to be negative, can I say something about the angle between these two vectors? It's an obtuse angle, yes? Because I told you that whenever you dot product two vectors, if it turns out the answer is negative, the angle between those vectors is bigger than 90, less than 180. If you ask me how much exactly, I don't know, but I know that this is correct. We can calculate it, by the way, later, but not now, okay? So this is one question. Here you see that one type of question I have directly asked you about the dot product, but I can also somehow indirectly ask you questions that you need to understand. You have to calculate the dot product, okay? So for example, I would say that this would be the last example. Are we finished now?
2 minutes.
Okay, so I will write it here. You can. Let me write exercise. So I will just write it down and then we leave it for you, and then I will solve it next. So I would say let U, V, and W be non-zero vectors let me write non-zero and mutually I forgot how to write mutually. Is that right?
Yes.
Okay. And mutually non-parallel vectors determine the angle between let me see, what are they supposed to be? The angle between U and this a little bit weird combination of vectors. U, W, but let me check everything is okay. U dot W V minus U dot V W. Yes. Determine the angle between this vector and that vector. I just want to mention, you see that I am not asking you about finding the dot product, but whenever the angle between the vectors matters, you need to think about dot product yourself. Yes? So I will leave this as an exercise. You need to understand, there is no dot here, there is no dot here. So that's exactly, let me double check everything. Yes. So I want you to find the angle between this U and that vector. Okay. Any questions? Okay, thank you. See you in a few moments.